Alright, morning everyone.
Morning.
I'm Jovie from engineering training. So we are all here today for this training, 330-200/300 Rolls-Royce Trent 700 ground handling. Okay, so I will explain more about Airbus A330 and the options of engine later on, okay, as we go through the course. Okay. So here's the course outline that we will be covering. So for this, the intention for this training is to have a general familiarization, which is a level 1 information, which is dedicated for aviation ground personnel. Okay, so by the end of this session, you all will be able to apply the required knowledge and competency to carry out the task in a safe and efficient manner so that you know what are the systems available on the 330 and how to do a very basic handling, ground handling and also servicing. Okay, have a general understanding on the aircraft system. So it's only for level 1, a very surface level 1, but at least you will get a little bit of awareness how the aircraft looks like. Okay, so duration for this training will be 2 hours and is dedicated for all aviation personnel. Okay, so let's have a look at the modules that we will be covering for today. So the training itself is divided into 4 modules. Module 1, we will cover introduction, ice braking and general info. And Module 2, we will cover aircraft general systems. Module 3, we will continue with the remaining of the aircraft general system. And lastly, Module 4, we will do a quick recap on all the systems and we will have a Q&A session. So if you have any question anyway, you can ask me during any modules, but you can also reserve it during the last module, which is Module 4. Okay, so far, do you have any questions on the course outline?
No.
Okay,
How about the timing?
The timing, Module 1 will be 30 minutes, Module 2 30 minutes, 3 will be 30 minutes, and Module 4 will be 30 minutes. So in between each module, we will have a 5 to 10 minutes break. Okay? And total duration will be 2 hours. Any other questions? Good. Okay, so we start with the introduction. So a little bit about my background. I started off my career as a trainee aircraft maintenance engineer back in 2005 with Malaysia Airlines. And in 2010, I became a base maintenance engineer, type rated on a 330, which is this training, and also on a 747. Okay, so in 2015, I decided to switch my career path and become an instructor. So 2015 to 2018, I'm attached to Malaysia Airlines Training School. And in 2018 until now, I'm with CAE as an engineering training instructor and also focus on the type training on the 330 and 330 related subjects. So my expertise is more towards the B1.1, which is the airframe engine and also the electrical topics. Right? So I would like to know a little bit about yourself also since the ice breaking session. We can start with you, Mr. Mazrul.
Hi, my name is Mazrul. I've been in line maintenance, aviation, 3 years. This is my second job.
Okay, thank you very much, Mr. Mazrul. So I believe you have a lot of experience on and exposure on the Airbus 320 and also 330. Anyway, if you haven't touched a 330 before, this 330 is like a bigger brother of a 320. So the system, I would say, is like 80% to 90% similar to what you have experienced before. So that will be easier for you to catch up the systems. Okay, thank you very much, Mr. Mazrul. What about you, Mr. Jovie?
Hi, I just joined this company 2 months ago. I'm from tech service department. This is my first job in aviation. Hopefully, I can understand more on 330 as I attend this class.
Okay, no problem. Even though it's a level 1 training, if you have any other things you want to ask, I will explain further as we go along. Okay, so good to have you, Mr. Mazrul and Jovie. So, any other questions before we start? Okay. Okay, so before we start our training, I will show you a little bit about the safety briefing in case some emergency happens or if there is a fire condition, we know what to do next. Okay, so as usual, safety is CEKL's priority. We always start with the safety. So if you have any issues or especially the fire bell, if it rings up, immediately we stop the class and we run to a designated safe area. So everybody's full cooperation and commitment is very much appreciated. Okay, thank you very much. And safety is everyone's responsibility, including you and me. Okay? So know where the emergency exits are. Okay? So first thing, if you want to look for emergency exit, this is the sign, okay? And this is the assembly point, and this is the emergency exit. So we have one of the closest here. Immediately go outside of this classroom in the left, you will find an emergency exit. And the emergency assembly area is at the car park behind here. Okay? So I will show you more. So emergency evacuation plan. Okay, so near to the fire control panel, room walk away. So we have another one in front of the Bangkok room walk away. And then access way near north wing reception counter. Middle staircase, south wing near reception counter area, and near cafeteria exit door area. Okay, so near to Batam classroom. Okay, so the closest one that we have, I believe is using number 4, and you can go through the cafe area, and the emergency assembly area is at the back. Okay, so you pass through the pool, and you have a car park area around here. Okay, so that is the emergency escape path. Any questions on the emergency evacuation plan? Okay. So currently we are on the first floor. So first floor we are currently using Labuan Kuching. Okay, where is the Kuching classroom? So the closest exit is on number 4, and you can exit from go to the ground floor just now, and you can get out from the cafe, and you can go to the emergency assembly point. So there are 2 car parks. The one in front is car park A, and the one at the back is car park B. So you can locate this side, you just go to the car park B, which is more spacious. And in case of any issues, we will go there and we will do a head count to locate any missing personnel. Okay. So anyway, any issues, you just follow me. I will bring you to the emergency assembly point. Okay. So if you spot an emergency, what do we have to do? We need to raise the alarm. We need to shout emergency, emergency, emergency to get awareness, okay? So that our emergency response team can start to do something about it. So if it is a fire, we can try to extinguish. So to extinguish a fire, you can follow this keyword, which is pass, P-A-S-S. We start with the P, which is you pull the pin. So A is aim at the fire extinguisher at the base of the fire. So we also need to be careful where is the wind direction, so we don't do it against the wind direction, because that would not be effective. Okay. And lastly, okay, once you aim it, then you squeeze the handle, and as you sweep, okay, from side to side of the base of the fire to put off the fire. So break the nearest brick glass so that the alarm will sound, and also will be notified. So if out of control, exit to the nearest exit door and proceed to the assembly point. So the keyword, if you have any issues, just run away. It's more important to save yourself first before anything else. Okay. So first aid kit location, we also have a few first aid kit available. The first one is on the bridge linking to the north and south wing. And the simulator bay, we also have a first aid kit. And lastly, outside south wing office, just in front of here, we also have emergency escape kit. Sorry, we have a first aid kit. Okay, emergency announcement, how do we make it? So we shout, when you hear emergency, 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 when an emergency announcement is made, evacuate immediately. So just stop whatever you are doing, especially your belongings, just leave it in the classroom. The most important thing is to save yourself. So here's the nearest exit, assemble at assembly point. So just a quick recap, okay, what do we have to do in case there is an emergency. So report to incident controller at command post. I will be there as well, and I will do the head count, okay, to confirm everyone is safe. Okay. General safety at the car park. Do not drive fast in the vicinity of CEKL. Okay, so yeah, we do have a speed limits. Follow speed limit, be mindful of pedestrian and vehicles, Be careful and considerate when parking or removing vehicle. Pedestrians to use designated walkways. So always be alert of moving vehicles. Okay. So safety inside the building. Do not tailgate or jump over turnstile, check-in, access way. So just wait for your turn up because of the gate. Only one person can exit at a time. Can enter and exit at a time. Report all hazards using QR codes reporting platform or inform your instructor of any CEKL staff. Okay. So any issues, we do have a QR code. In every classroom, we should have a reporting QR code that we can use for incidents or near misses. Use water dispenser machines hygienically. Keep a 1 to 2 cm distance between the mouth of your bottle cup and the spout. Okay. So beware of slippery floors, especially restroom. If you see a sign of a slippery floor, do slow down as you're walking at the way. Hey, safety at the staircase. Do not read or send messages via handphones while walking on the staircase. So if you want to text or call, just stand still up instead of walking, right? So to prevent any accidents or incident. If need be, move away from the stairs to a safe place, and also don't block others from using the stairs. Follow safety guidelines posted at the staircase area. Always have one hole on the handrail. So carriage of bags, books, hang over your shoulder or grip with the other hand. Have firm footing on the steps. So basically, we just practice common sense, okay, and also awareness. Okay, smoking areas. Smoking is allowed in CAE, just that you need to go to a dedicated smoking area for a proper procedure. So smoking areas, there are two. One is on the outside of the north lobby, another one is behind the cafeteria. You can go all the way to the back here. You have a dedicated smoking area. So smoking only at designated areas. All other areas in CAE is prohibited, especially in indoors, which is air conditioned. So no smoking is allowed. Okay, that's it for our safety briefing. Any questions so far?
No.
Okay, right. So all good. So remember, if you have any emergency, you hear the fire bell, emergency, immediately stop all your activities, including myself. We need to run away to the assembly hall. Okay, that's the key. Okay, so now I will move on to a little bit of an introduction before we move on to the real topic. Okay, so this is the code for this training, AC012. Okay, so first thing, this is an Airbus A330-200/300 fitted with the Rolls-Royce Trent 700 engine, ground handling course. So I will talk a little bit about the 330 configuration before we start. Okay. So 330 was started all the way back in 1990s. So the timeline is after 320. Okay. So at that time, 320 is a very successful aircraft which incorporate a fly-by-wire technology, which at that time is considered not that mainstream. It started on a commercial aircraft with a fully fly-by-wire system, and it was a success. Okay. So at that time, Airbus have an older configuration which is still fly-by-tables, which is an A300 and A310 series. So they want to replace this aging wide body which uses fly-by-wire technology. So what they have done, a few years after introduction of the 320, they transfer the 320 technology into an A300, A310 body, so to become an A330 aircraft family. Okay, so it started all the way back in 1990s. So at that time, there are a few variants available. We have a Dash 200 and a Dash 300 aircraft. So Dash 200 aircraft is shorter, but it has a center tank. Okay, so it can carry more fuel even though the aircraft is shorter. So for Dash 300, we have a center wing, but it doesn't store any fuel, and the aircraft is longer. Okay, so now the options depending on the airlines and the operators, which kind of operation they want to use. If you want to fly a longer range but carry less passenger, then it's preferably to use a Dash 200 aircraft. If you want to fly a shorter range but carry more passenger, and then Dash 300 is a more suitable option. Okay, so depending on the variant. So besides that, we also have another variant called Dash 200 Freighter. So Freighter is more common to use a shorter fuselage Dash 200 variant. Okay, so we have 3 engine options available. is Rolls-Royce Trent 700 that we will be covering in this training. The second variant is Pratt & Whitney PW4000 series. The third option is the General Electric GE CF6, which is very similar to CFM56, just as it's larger. Okay, so 3 engine options. Okay. Somewhere in 2018, they have updated the variant. So now you have a Dash 330, Dash 800, and Dash 900, which is a new aircraft, new engine option. So the updated version, they have scrapped all these 3 engines and replaced by 1 engine only, which is Rolls-Royce Trent 7000 series. Okay, so only 1 engine options available. So why do we have a Dash 8 and Dash 900? Because Dash 800 is actually Dash 200 Neo, Dash 900 is Dash 300 Neo. So 1 shorter variant, 1 longer variant. Okay, that's all. So if you want to order an Airbus 330, nowadays you will not get any of the older 3 engines. You by default you will get 1 engine only, which is Trent 7000 engine, which is the latest variant. Okay. Any questions so far? Good. 340. Okay, so we also have a very weird configuration, which is A340. So this 340 is not a standalone aircraft type. It's basically an extension of the 330. So before they come up with the 340 is basically a 4-engine 330. So 340 can fly a further range. That time EDTO or ETOPS is not that popular. So that was like during 90s. They still prefer multiple engine aircraft, which is more than 2 engines, to fly through a Pacific Ocean area. So that time 4 engines aircraft are very popular. So they come up with a 4-engine 330, but the code is, the model number is a 340. For 340, you will not get a standalone type training. What you will get, you need to go through a 330 type training, then you go for differences training. Okay, so I would say the major difference is instead of a 2-engine, it becomes a 4-engine. Right. But for 340, there's only 1 engine variant, which is CFM56. It uses a smaller engine, but now we've got 4 engines. Okay, so that is our 340. So in this training, some of the diagram you will see is a 340, but it's not applicable to us anymore because 4-engine aircraft nowadays are not that popular and it has been phased out, okay, and slowly replaced by a twin-engine aircraft. Nowadays, a twin-engine aircraft, for example, like an A350, you can fly for a single engine. Now you can fly for 370 minutes for the maximum rating to the closest diversion airport. Okay, any other questions? Good. But for this training, we will only focus on the current engine options. So this is the engine this aircraft variant that we will be covering, and Trent 700. Okay, because it is for the age and XP. Alright. Okay, that's all for introduction and ice breaking session. Any questions so far? Okay, so I think we take a 5 minutes break and then I will continue with the module 2 and module 3 afterwards. Alright, welcome back everyone. Let's continue with the training. So we will continue with the module 1. So the condition for this training notes, as usual, this is just a training notes. When you are working on the real aircraft, do not use this as a reference. Always refer to the latest revision of the aircraft maintenance manual. So for Airbus, you can refer to NF. Okay, you can also go to Airbus World, but that will require a username and password for you to access the references. Okay, so general information, which is module 1. Right, why do we see a map of a European continent here? Because it's a joint venture of YASA countries, which is an EU kind of a thing. So Airbus is not manufactured by a single country. The type certification is given by YASA, okay, European Aviation Safety Agency. So mainly there are 4 countries which are involved heavily in different parts of the aircraft structures and also engine. Okay, so first off we have a UK. UK focus on the wing. So the left hand and right hand wing is mainly manufactured in Broughton and also on the Filton, which is part of the UK. So in Spain focuses more on the tail section. So on the THS and empennage area that is produced by Spain. And France focuses more on the cockpit and also center fuselage. The rest of the fuselage section is manufactured in Germany. Okay. So how do we assemble all of these different sections into one single unit? So for Airbus, we need to look for final assembly line. Okay. So all of the different sections will be shipped to Toulouse. So for 330, the final assembly line is still in Toulouse. Hamburg is mainly for a narrow body, which is an A320. Okay, so once different section is shipped to Toulouse, so one of the famous aircraft that we use is a Beluga, which is a very odd shape and a big aircraft, which can be used to ship sections of wing and also fuselage to the final assembly line. So in the final assembly line, the production line will just assemble everything together, and after that they will do various tests and also carry out the flight test in Toulouse before they release the aircraft to the customer. Okay, so that is just how it works. So yeah, any questions so far? Okay, good. So again, it's a joint effort and also joint venture of various countries. So this picture and diagram here shows different colors, which is manufactured by different countries. So just like what I mentioned before, okay, red color is France, cockpit, radome, center fuselage and pylon that is manufactured by France. Airbus Germany manufactures other fuselage area section and also inboard and outboard flap, including the spoilers. Okay, whereas Airbus UK mainly focuses on the wing, okay, the landing gear doors and also the winglet. Okay, lastly on Spain focused on the tail section, which is on the THS. Okay. We also have some Airbus subsidiary like a Bell Airbus, I believe is a Belarus Airbus. That one they just manufacture on the slats. Okay. So GE, PW, and Rolls-Royce, those are engine options. So engine itself is manufactured by different manufacturers. For us, the Rolls-Royce Trent 700, that one is manufactured by Rolls-Royce. So just now we asked about the 340. So now you see the picture of a 340. So 340 is literally just a 320 fitted with the 4 engines, but with the smaller engine option, which is CFM56. Only one engine option is available. So for 330 class, we can just ignore about this stuff. There's only two engines available. Okay, Spain apparently also manufactured the doors. The doors are manufactured by Spain on the passenger door side. Any questions so far? Good. So for aircraft, we have ATA chapters. So for ATA chapter 06, it talks about zone and station. These are the typical things that we will cover in ATA 06. References exist. So reference exists, we have X, Y, and also vertical axis, which is Z. Those are mentioned. And what are the reference points? Those are mentioned in the zone and station ATA chapter. And next we have aircraft dimension, the nose to tail and the wing to wing dimension, and also the height of the tail fin. Those will be mentioned later on. Section and station numbers. So section and station numbers is more for Airbus references. So in case you have any structural defect, you can also use that to identify and pinpoint where is the exact location that we have a structural damage, like a dent or a corrosion. Okay, access panels is also covered in this chapter. So we have specific numberings, so you can identify which access panel to remove in case there's an inspection call out. And lastly is the zone presentation on different zones of the aircraft. Okay. Any questions so far? Good. Okay, let's move on. Okay, so we start with the reference axis, which consists of X. X is the longitudinal axis, which is from the front to the back of the fuselage, so in the longitudinal plane. Y axis is lateral, which is the wing to wing axis. Z is the vertical axis. So just like any other aircraft, we will focus on this 3 axes to locate where is the component location and in case there is any structural damage. Right. So for longitudinal axis, we have a datum line. The datum line by default it's 251.2 inches forward of the nose. So again, most of the aircraft we use the datum line at an imaginary point in front of the nose now. Okay, typically for 2 reasons. One is for easier C of G calculation, so that you will get a positive number every time you calculate it. And this datum line can be also used to place the dockings during assembly at the final assembly line. So regardless this is a dash 200 or dash 300 variant, you will use the same datum line so that you can place the dockings accordingly and adjust accordingly. Right. So the datum line, just for your info, is not at the tip of the rudder, is 251.2 inches. So for Airbus, normally we use a metric system, so the reference is in millimeters, either centimeters or millimeters. So if you convert into millimeters, that will be 6382 millimeters. Okay. Okay, next, the aircraft dimension. So for both variants, dash 200 and dash 300, the wingspan is exactly the same. Okay, the wingspan is roughly 60.3 meters. So to give you a comparison, this is roughly 2 320s parked side by side. So that is how big a 330 is. Okay. So both dash 2 and dash 3 have the same wingspan, whereas the nose to tail, that is where it differs. So for dash 200, I mentioned before, this is the shorter variant. So from nose all the way up to tail is 57.51 meters. If you see dotted line like this, means it's a dash 200 variant. So for dash 300, the longer variant, we have roughly like 5.3 meters extra. So I think you have like a 10 frames extra to make it longer. So you can put in more seats to carry more passengers. But something weird that you will notice is when the fuselage is longer, the tail will be lower. Okay, but when you have a shorter fuselage, the tail will be higher. Is there any particular reason why you design like this? Why a shorter fuselage with a higher tail fin? Why a longer fuselage with a shorter tail fin? If you notice, the shorter fuselage is 57.5, right? But the vertical fin is actually taller, 18.2.
Same characteristic.
Yeah, correct. Okay, this is actually to maintain the longitudinal stability. So for pilots, they don't need a separate training. If they know how to fly a dash 200, they can also go into the cockpit and operate the same way like a dash 300 aircraft. So these are the physical modifications that they have changed. And also have the same turning moment when you move the rudder. Okay, so basic aerodynamics, when you got a shorter fuselage, the tail fin will be taller. Okay, so on the dash 200, the tail is taller, so you need to have a bit higher excess if you really want to reach the tip. And also the rudder should be of a different part number because the rudder is taller also. Okay. So the clearance between the lowest part of the fuselage to the ground is around 1.85 meters. Okay. So since it's roughly 1.85 meters, it can be a bit hard for you to reach the access panels. Because at my height, mine is 1.73 meters. I might have problem touching the fuselage also. So what you need is always a stack with you. You need to carry a special tool, which is a stack, so that you can reach the refuel panel and also the servicing panel for hydraulic system. If not, you might not be able to reach it. Okay, because this is the clearance. Okay. So just like most of the aircraft is a tricycle type of a landing gear design. We got the nose gear with 2 wheels. The main gear, left hand main gear and right hand main gear. Each main gear got 4 wheels. So you have a total of 8 main landing gear wheels incorporated with also brake system so that you can spread the load more evenly. This aircraft is very heavy. It is a wide body aircraft. How do you differentiate between a narrow body aircraft and a wide body aircraft?
Single aisle,
double aisle. So like this classroom, we got one walkway. This is a single aisle. So for 320, we also call it a SA, single arm. So for 330, 350, 380, you got 2 or more arms or walkway, we just call it a wide body aircraft. And for information. Okay, next part is the section and station numbers. So if this fuselage is just like a cake, you can cut it into 5 different sections. So for Airbus, normally we have a cockpit all the way up to door number 1. We call it nose forward fuselage. From here up to before the center wing, we call it forward fuselage. And the center wing and the fuselage, we call it center fuselage. Half of it, we call it rear fuselage. Half of the pressure bucket. So pressure bucket over here will separate the pressurized zone and unpressurized zone. So anything out of the rear pressure bucket, we just call it code as /rear fuselage. Okay, so it's separated into 5 zones. Okay, so some other references that we use to determine where is the location, we use station number and frame number. So frame number, we have frame number 1, which is on the forward pressure bucket. So the rear pressure bucket, we call it frame 80. So over here, we have different frame numbers. For example, frame 18, the distance between the datum and the frame 18 is 1340 centimeters. So they call it station 1340. Okay, so as you move to the up section, for example, frame 80, it will be station 6061 because it's 60.61 meters from the datum line. Okay. So you also notice that there is a dotted line. For dash 200, since the fuselage is shorter, frame 80 is somewhere around this area. So the distance is different. So even though it's the same frame number, the station number differs, which is at a much forward area, which is 5529 centimeters from the datum line. Okay. So always refer to AMM 06 and also SRM, Structural Repair Manual, for the precise station number. Okay, because if you, let's say you have both dash 200 and dash 300 fleet in a company, even though for the same frame number, the station number is different. And also if you have a shorter variant like the dash 200, I think there are 10 frames which is missing because to make it into a shorter fuselage. Okay. So any questions over here? Good. Okay. So nacelle and engine also have a station number, so we call it nacelle station number and also engine station number. But what we focus here will be Rolls-Royce Trent 700. Okay, so the nacelle itself will look a bit different depending on the engine variant. So let's say you have a 330 fitted with the Trent 700, the pylon on nacelle is only compatible with this engine. So you cannot simply swap another engine into a different nacelle. So a different pylon. The pylon needs to be compatible. Especially for Rolls-Royce Trent 700. So Trent 700 is the heaviest out of these 3 variants. So to give you a comparison, the PW is roughly 5 tons. Trent 700 is 6 tons. Okay, 1 ton extra. So you need to carry extra weight and strength. So the pylon itself is further reinforced. Okay, on the Rolls-Royce Trent 700. So if you look at this comparison of the side view of the engine, you will also notice one thing. Trent 700 seems like it's much longer compared to the rest. Okay. So from afar itself, you will notice that it's a Trent 700 because the reverser cowl actually covers up to the exhaust area. So most of the engine, the exhaust area is exposed up like this. Whereas the Trent 700 will cover all the way to the back. So according to Rolls-Royce, this will make the secondary airflow and the primary airflow much nicer to generate more thrust. Okay. So the exhaust blast is more concentrated on the Trent 700, and by far out of this 3 engine, Trent 700 generates the most thrust, okay, which is roughly 72,000 pounds of thrust. Okay. Right, so we have a Rolls-Royce Trent 700, PW 4000, and GE CF6. 3 engine options available for current engine option series. Okay. Okay, so different sections of the aircraft is also classified by different zones. So again, this is quite general. It's a generic zone number between Boeing and Airbus. They use the same kind of coding. So for zone 100, zone 100 is a lower fuselage. You can further divide zone 100 into forward, 100 forward, 100 center, 100 alpha if you want to. So you can refer to the task card. Normally they will follow the zone number. So upper fuselage will be zone 200. Okay, zone 300 is on the stabilizers and the rear fuselage. The empennage area is zone 300. Zone 400 is nacelle and pylon, number 1 and number 2 engine and number 1 and 2 pylon. 500 is left hand wing, 600 right hand wing. 700 is the landing gear. And we also have zone 800, which are the doors. So the doors includes the passenger doors, the forward cargo door, avionics door. So anything parked under the door is under zone 800, which is the same for Boeing and Airbus aircraft. Any questions so far? Good.
No question.
No questions. Right. Okay, so this diagram shows you what is the maximum takeoff weight. So we can ignore about 340, sub 340 already been phased out in our fleet. So our main focus is the Dash 2 and Dash 300 aircraft. So I mentioned that Dash 200 is a shorter variant, Dash 300 is a longer variant, but the maximum takeoff weight is still the same, it's 233 tons. In fact, Dash 200 is even slightly heavier, 192 compared to 184, which is the lowest of the Dash 300. So anyway, I would say that they are more or less the same. So if you fill up to maximum, maximum takeoff weight is 233,000 tons. Sorry, 233 tons. That is the maximum takeoff weight. How come a shorter aircraft have the same weight as a longer aircraft? Yeah, fuel tank. Because Dash 200, to extend the range, the center wing carry fuel. So that is the main contribution. Why even a shorter variant has the same weight? Okay. So Dash 300 is longer, but it doesn't have a center wing. So more or less, it has still the same 233. Okay. Okay, next part is the servicing point. So for ground handling, the servicing location is very important so that you park the equipment at the correct place. So for servicing, we will start with the number 15, oxygen system. Okay, so oxygen system, we used to do oxygen servicing in situ, but now this has been banned by the authority, which is CAM. So in situ oxygen servicing is not allowed anymore. Anyway, previously, if you want to do in situ servicing, oxygen bottle for flight crew is inside avionics compartment. Okay, point 15. Point number 1 is electrical ground power. So if you want to connect the GPU connection is near the nose landing gear area, but it's aft of the nose landing gear. Okay, and since it's a wide body aircraft, you need to, if you want to have full power on the aircraft, you got 2 external power connection, which is A and B, okay, to provide full power. Okay, point number 2, we have a remote water drain. We have a forward remote water drain, a tank remote water drain. Water servicing, can do it at the back. Okay, we have a water servicing panel at the back. Next to it, we have a toilet servicing panel. Okay, point 16. Low pressure preconditioning. This is basically your aircon supply. Aircon supply, we got 2 connections on the forward side of the belly fairing area. Another 2 connections for HP, which is point 14. High pressure air conditioning, engine starting. So normally we use GTSU, gas turbine starting unit for engine starting, and for BS turbine. So it's a wide body aircraft. You've got 2 connections each to fill up air to the fuselage and also the big air system. Okay, if you want to do refueling, we can go to point 17. Point 17 is where your refuel panel is located at, where you can select how much fuel uplift you want to do to carry out automatic refueling, manual refueling, and also transfer fuel and also defueling operations. You can choose it here. Okay. So for hydraulic servicing, we have 3 panels here, 0.7, 0.8 and 0.11. So 0.11 at the aft is the green servicing panel. Forward of the main landing gear wheel well, we have a blue hydraulic servicing panel. On the right hand side, we have a yellow hydraulic servicing panel. On the engine, we can also do servicing. So point number 3 is IDG. You can do IDG servicing. And you can also do engine oil servicing on the engine. So for Trent 700 engine, engine servicing is on the right hand side of the fan cowl. Okay. So point number 13, this is a fuel pressure filling. So if you connect to the fuel bowser, okay, we got 2 connections, each up, 2 on the left and 2 on the right hand side. Okay, so we have a total of 4 fuel couplings on the aircraft. Fuel gravity filling is a provision. So in case you diverted to some airport without this pressure filling provision, you can use a gravity filling on top. You can open up a gravity filling port and you can just do a gravity filling. But it's very rare to use this. And lastly, at the back, okay, what do we have at the back here? Any idea? We have also a third engine here. APU, yes. APU also requires servicing. Okay, so APU servicing, we go to the APU compartment, and on the left hand side, you can do APU oil servicing. Right. Any questions on the servicing points? No. Good, huh? Okay, service arrangements. So just now we covered the servicing points. The servicing equipment and the vehicles will just park next to the servicing points. Okay. So point 13, we have a GPU to supply electrical power. Okay. So normally for passenger embarking and disembarking, we will use the left-hand doors. So we got door number 1, number 2, number 3, and number 4. And normally number 3 is not used. This one is more for emergency evacuation. So for passenger boarding and disembarking, we use number 1, number 2, or number 4, depending on the airport operations. On the right-hand side, reserved for catering. So the right-hand doors is reserved for catering operations and also to load and unload cargo. So we have a forward cargo, aft cargo, and also butt cargo loader stuff that we can park. So at the back here, we also have a water and waste servicing truck to do servicing of the water system and waste system. So the refuel truck or bowser, we just park it under the wing. Okay, so on the left and on the right. Normally we will use on the right hand side, but let's say you want to speed up the refueling process, you can hook up both left and right at the same time, maximum 4 connections. That is allowed on the 330 to shorten the refueling time. Okay. So for HP and LP Air, we can use pneumatic card. So we have an aircon card and also GTSU that you can park. So any questions on the service arrangements? Rhoda? Okay, so next, jacking. Okay. When do we use jacking operation? When do we need to jack up the aircraft? Any idea? What kind of operation requires jacking?
Landing gear retraction.
Yes, landing gear retraction test that you need to jack up so that the wheels is off the ground and only you can retract the gears, right? Okay, so that is one of it. So if you involve with the hangar operations, you also need to jack up the aircraft to support the weight because there's a lot of COG changes during the removal and installation process and also the equipment. And if you want to change the wheels, you can also jack up the landing gear axle just to do a wheel change. Right? So if you want to do a main jacking of the aircraft, you jack up the aircraft. The main jack point is on the wing. Okay, outboard of the landing gear, sorry, on the rear spar. So another main jack point is on the forward, okay, fuselage area. So all 3 jack points, we will need to install adapters. So you just locate at this symbol. This symbol is a jacking point symbol. So you need to remove the blank, install a very heavy jack pad, and then you can jack up the aircraft. Okay. So we have a safety point also at the back. So for Airbus, the safety point is at the back. It looks very similar like the jack location, but we don't use it for jacking. The one is more for safety the aircraft and for extra support. So once you have jack up forward and also the wing jacks, to further support the aircraft, you just have to load up the safety point a little bit. Okay, but never ever go and jack up the aircraft using a safety point. You can overstress the fuselage and you can puncture the fuselage. Okay. Any questions so far? Checking points. So if you have been involved with the 320 operations, this is very similar in location. Okay, during jacking, we need to make sure that the aircraft is level when you jack up. Okay, so if you have exposure on Airbus before, normally how do we do leveling on jacking?
MCDU.
Yeah, you can use MCDU. So what we do, we power up the aircraft, you align ADIRU 1, 2, and 3, and then from MCDU, you can access what is the pitching attitude and the rolling attitude in the digital format. But for 320, the page that we use is called AIDS, Aircraft Integrated Data System. So this is the 320 one. 330, we call it ACMS. Exactly the same thing, but it's in a different different name. So Aircraft Condition Monitoring System. So you go to MCDU, you access ACMS, go to Alpha call up, and you just key it PECH. Okay, you press here, then it will show you what is the pitching. Press ROL, you will see what is the rolling attitude here. Okay. If you don't have electrical power for Airbus, you can use another method, which is you need two spirit level. You can place it on the forward fuselage or forward cargo. So you just make sure the bubble is in the middle. The third option available is this one, attitude monitor. But this attitude monitor is only installed on the older configuration. So what you need to read, you go to the review panel, okay, this alpha numerical read. You want to make sure the bubble stays at the middle, which is the default. So that is how you make sure the aircraft is straight and level. Okay, but this attitude monitor has been removed from later configurations. Okay, so you can actually check leveling with or without electrical power. The easiest method is power up the aircraft and use ACMS. Any questions?
Jet the aircraft using PCM.
What is it?
Can we jet the aircraft while using PCM?
Yeah, you can jack the aircraft while using ACMS. Just that you need one person to be inside the cockpit. And also once you have jacked up the aircraft, you also need to prepare a stair so that the person can come up from the cockpit. While you are powering up the aircraft, you need to be careful because when you jack up the aircraft might go into air mode. So you need to also do some safety precautions and safety certain system to prevent any accidental operation of the aircraft systems. If the aircraft accidentally go into air mode. Some of the things that might happen is your probe heating will start coming on automatically. Your avionics cooling system might go into air mode also. Right? So you can actually do some setting and safety precautions before you proceed with the operation. So anyway, if you refer to EMM, it will tell you what to do. Okay? Very precisely. Any questions? Right. So the last topic before we end our module 1, module 2, is that aircraft weighing. So aircraft weighing means you need to weigh the aircraft. So again, there are a few ways. The most easiest way is by using a weighing platform. So you just place it on the floor. So you just tow the aircraft so that it can sit on top of the weighing platform, and then you just read what is the reading on the weighing platform. So another type of weighing, you can install it between the jack point and the jack, and you can read what is on the load cell. But that is less common. The most easiest one, you need to prepare a weighing platform so that the wheels can sit on top of it. So you need like total of 10 wheels, right? You need a 10 weighing platform. So once it's sitting on top, normally the tech service engineer in each airline or KMO, they will come over and do a calculation of the COP, okay, to update the mass and balance schedule. So you can find the weighing procedures under 8808. Any questions? Okay, all good. Right, so let's take 5 and then we will continue with module 3. Okay, thank you very much. Okay, welcome back everyone. So far, any questions on module 2? No, good question. Alright, so we will continue with module 3, which is a continuation of general information. Okay, so the next chapter we will cover briefly will be 8809, which is towing. So towing, normally we use this method, which is towing from the nose landing gear. But there are also abnormal towing that you can tow from the main landing gear, but that will not be covered in this training. That one is more for abnormal occurrences. If let's say aircraft speed off the runway, there are provisions that you can tow from the main landing gear as well. Okay? But the common towing is normally is for pushback operations and to reposition aircraft. We just use on the nose landing gear. Okay, so first thing, towing on the nose landing gear, we need to locate where is the towing point. Okay, so we have a towing point, and also we need to use a proper tow bar which can support the aircraft weight up. So normally the tow bar itself got a part number, and it should be there's also model number which is painted on the tow bar so that you don't use the wrong tow bar. So if you use a weaker tow bar, it might shear off, and that can be very, very dangerous. So always use a proper equipment. So we have a tow bar connected to a tow truck. Before we start towing, we need to make sure that the nose landing gear is properly serviced. So the dimension H will show you what is the servicing height. If a dimension H is too much, it's fully extended, or if you don't see any dimension H at all, you shouldn't start the towing operation, because if you tow in an over-service or under-service condition, you can damage the nose landing gear, which ultimately it might result in a nose landing gear replacement. Okay, in the worst case scenario. Okay, so towing involves aircraft movement. So the minimum manpower for towing, we need one crew personnel in the cockpit, one on the headset, and also a tow truck driver. So since a wide body aircraft, you might need additional personnel also at the wingtip and at the tail, in case you have another aircraft in the near vicinity. Okay, so just to make sure you have sufficient clearance during movement. Okay, so one precaution is very important here. If you were the personnel inside the cockpit, always make sure you wear a seatbelt. Okay, so seatbelts is a warning here. The seatbelts are fastened during towing and taxiing operation. Low speed operations included. So the concept is just like you are driving. So since the aircraft is in motion, if the tow bar shears or the aircraft jerks suddenly, you might fall off the seat and you won't be able to apply the brakes on time. Okay, so you yourself must secure with the seatbelt if you were inside the cockpit. Okay, so there are some information here as well. So the towing forces, so the breakaway force is 6% MTW. We also have a rolling, breakaway on slope, and also rolling on slope. So towing is mainly for pushback operations. Why do we need a pushback operations? Why do we need to push the aircraft backwards?
No reverse gear.
Yeah, no reverse. Even though the aircraft got a reverser, theoretically you can reverse the aircraft, but aircraft operation doesn't allow you to do that. So you will need to use a tow truck to do a proper towing and a pushback. So some other information on the taxiing. Okay, taxiing means the aircraft is moving on its own power. So when pilot want coming close to the bay or getting into the bay, they are doing taxiing operation in the forward direction. So for taxiing, there are a few dimensions available here. So we need to take note that dash 200 and dash 300 got a different fuselage length. So the turning radius on the dash 300, which is a longer variant, definitely you need a larger turning radius one, and you will need more clearance when you are doing taxi or turning operations. Okay. So in case you are not confident, you should place more personnel on the wingtip and on the tail, especially during towing operations. So minimum turning radius, we can find this information in 8809. Okay. This dangerous areas is very, very important for maintenance personnel. Okay. So any engine power higher than idle, there are no safe zones, so do not get close to the engine from the side. If you get too close to the inlet, you can get sucked into the engine. You get too close to the exhaust, you can get pushed away by the thrust generated by the exhaust. So inlet and exhaust is extremely dangerous. Even the side, there are no safe zone. Alright. So for 330 fitted with the Trend 700, this is the mapping here, and we have a CF6 and PW for 168. So from this picture, looks like Trend 700 is a bit safer compared to the rest. So if you look at the inlet, it's much smaller, the danger zone. The exhaust is almost similar. But don't get fooled by this picture, because if you read it carefully, the exhaust blast on the Trend 700 is much more concentrated. So you can actually reach a further length compared to the rest. So for comparison, Trend 700 exhaust blast can reach 640 meters, which is roughly 2 to 3 aircraft distance. Okay. Compared to PW is only 225.5 meters, and CF6 is 274. So it's almost 2 to 3 times further compared to PW and CF6. So I would say that on the Trend 700, you need to be careful with the exhaust blast. Make sure immediately behind the aircraft there's no vehicle park, there's no aircraft, there's no personnel behind it before you push to high power. Okay. So at minimum idle, you can get near to the engine and get away from the engine from the entry corridor, just like any other turbine engine but only up to minimum idle power. So normally from engine starting, if engine starting you cannot open the start valve, normally you can use the manual override method. That is when we use the entry corridor. But I would advise that before you reach idle, you should get away from the engine already. Okay? So entry corridor only exists from the side of the engine. They never ever go to the inlet, never go to the exhaust area, because that is extremely dangerous. Okay. Always observe safety precaution. Okay, next we move on to parking procedures. Okay, so to park an aircraft means that you power down the aircraft, you park it to prevent any accidental movement. Okay, so for parking we can refer to ATA 10. So there are a full list that on the things that we should do under parking. So we can refer more to it in ATA 10. So some of the things that we need to do during cold weather conditions, we need to do cold weather procedures. Clean the aircraft if necessary. Park the aircraft on a flat surface. Install the landing gear safety devices. So the landing gear safety devices, we have 3 safety pins on the nose, and on the main landing gear there are another 2 larger safety pins. Okay, flight control surfaces must be retracted, so we should normalize it. Let's say the flap and slat is extended, it should be retracted. Okay, THS set to 2 degrees up. Okay, so put the wheel chokes in position. Then ground the aircraft. Wheel choke is very important because your parking brake pressure can only last for 12 hours. So after 12 hours, you might lose the parking brake. So it's a standard procedure that we need to choke and make sure we have sufficient number of chokes. Okay, ground the aircraft. Refuel tank to a minimum of 30%. Okay, so we must have a minimum amount of fuel. So normally for 330-300, the maximum fuel is around 76 tons. So you should have like roughly 30% of it. Okay. Any idea why we need to have a certain amount of fuel in the aircraft? Why does it must be minimum of 30%? What will happen if we have less than 30% of fuel? Corrosion. Yeah, corrosion can happen, correct? Okay. Because we got more space and there are more condensation inside. But to avoid corrosion, we need to do a water draining every night stop. So for 330, every 3 days, we will do a water draining. Okay. So are there any other reason why we need to refuel it to more than 30%? Okay, so if you are not aware, the reason is if the aircraft is less than 30%, the aircraft can be too light. The COG is not in the correct range. Yeah, and especially when you do engine ground run, that can also affect it. So you must have a minimum amount of fuel. That also acts like a ballast to make sure the aircraft is stable. Okay. So drain water from all fuel tanks. So on this aircraft, Dash 200, what we have is on the wing, we got inner tank, outer tank, left hand and right hand side. Dash 200 also have a center tank. The DHS itself, Primable Horizontal Stabilizer, also can store fuel. That one we call it the trip tank. So all of these tanks we need to do water draining, so to avoid corrosion. So unfortunately, water droplets, you cannot prevent it 100% because of the characteristic of the kerosene. It will absorb water overnight. So once it absorbs water and the kerosene is lighter than water, water will go to the lower side of the fuel tank. So if you don't get rid of it, microbiological growth will start to grow, and that will also start a corrosion on the metallic structure of the fuel tank. Okay, so to minimize this problem, we need to drain every night stop. Okay. So open all window shades, close cockpit sliding windows, install protection equipment. So any probe covers, engine cover, and ABU cover, we need to install as per the okay. So one of the easiest way to close all external valve is that you turn on the power up the aircraft, turn on the ditching switch. Okay. So all the external valve like outflow valve, the aircon inlet doors and the outlet doors will go to close. The avionics cooling doors will go to close. So yeah, that is one of the procedure if you want to do a long-term parking. Any questions so far? Good. So if let's say our config is a dash 300, you still need to drain the fuel tank, just that there's no center tank. You only need to drain inner outer tank and the fuel tank. Okay, aircraft mooring information we can find it under ADA 10 table. What is the purpose of aircraft mooring procedure? Why do we need to do mooring?
Prevent movement of aircraft during high wind condition.
Yeah, correct. So even though in Malaysia that's not a problem, but let's say you park the aircraft overnight in the Philippines, in Hong Kong where you have a typhoon, the aircraft might jump choke because the wind can be strong enough to generate lift on the wing and the aircraft will be hopping. And if let's say the aircraft jump choke, it might not be able to stop the movement. It might displace itself to another place. So that's very, very dangerous. So to make sure that the aircraft is rooted to the ground, normally the mooring point we just tie it on the towing attachment to the ground mooring station. So we have a mooring attachment on the tarmac. If let's say we don't have a mooring provision here, we can also use something like a water ballast to tie it on the ground. Okay, to make sure that the aircraft doesn't hop and jump choke. So for more information, we can find under ADA 10. So for standard operations on aircraft, we will just use ground support equipment and tools. So we need to use tools which are registered. The approved tools must be registered in our system before we start using it. And as a standard practice, before we start the job, we need to count whether we have any missing tools. And end of the shift, we need to counter check again. Make sure all tools are returned to the common toolbox. Okay, to avoid any misplace of the tooling, especially if we have something operations like a fuel tank entry, because these missing tools can cause a maintenance issue later on and some system damage. Okay, so only use registered tools on aircraft. So for ground support equipment and tools, we can refer to a manual. Okay, we call ITEC, Illustrated Tools and Equipment Manual. So last time we have something like a DVD, but nowadays this has been digitalized and you can actually find it from AMF or Airbus Pro, so it's much more easier. So you just log into Airbus Pro. When you refer to EMM, let's say you have a hyperlink of a particular special tool, you click it, very likely it will link you to this manual, ITEC. So what it will show you is that what is the illustration of the special tool, how does it look like, how is it installed onto the aircraft system, and then it also gives you a part number and also what are the vendors that are selling this kind of toolings. Okay, so that you have a better idea how to use the tooling and how to get it in case it's missing in our system. Okay, ground support equipment and tools from our ground support equipment department. So again, these are generic, but you can use it on Airbus or Boeing. So the common ones, we have tripod jacks to jack up the aircraft. We have trolley jack, main landing gear flat tires axle jack for tire change. We also got a hydraulic axle jack. Sometimes you might have a flight away kit on the aircraft in case the aircraft need to do a wheel change at the remote station. You can also use the smaller flight away axle jack. Tow bar axle, okay, this one is common also. So these are the examples of the ground support equipment and tools. So what we need to check out is that the serviceable date of the tooling is correct, and also whether the tooling is suitable to be used on the 330, okay, before we use it. For jacks, we need to check what is the jack capacity, what is the maximum weight we can jack up the aircraft or the landing gear wheels. Okay. Okay, so next part we move on to plug up. Okay, decals and plug up which can be found in ATA 11. So there are three major classification of a plug up. So the first type, it tells you about component location. So in this example, this is a reservoir, green color reservoir. It tells you what are the individual components located on the reservoir. So this plug up is staked onto the reservoir or nearby the reservoir so that you can identify what are the components, okay, on that reservoir. Okay. So this one tells you the components for component identification. So the second type of plug tells you servicing information or maintenance procedures. So in this example, this is landing gear servicing plug. It tells you what is the dimension and what should be the pressure for proper servicing. So you can refer to the servicing band, referring to what is the current outside temperature, and you can find out whether the gear is properly serviced. Okay, so it gives you maintenance procedures. So the last type of a plug the last classification is for access. So what is behind the access panel? For example, you have a radio altimeter number 2 behind this access panel. So that is how you identify it. Okay, so just to summarize it, 8811 plug identification and plug will fall under any one of these three categories. Any questions? Okay. So now we move on to the cockpit. So a typical Airbus cockpit, you go inside the cockpit, one big component is missing, which is the control wheel. You will not find any control wheel on the modern Airbus one. So 320, 330, 350 and 380, what you will find is that you will find a side stick. Okay, so below the side stick there's only one electrical plug. It's a fully fly-by-wire system. So we have one captain side stick and one FO side stick. Okay. So what else is obvious feature of Airbus? So we have 1, 2, 3, 4, 5, 6 display units. So we have a primary flight display, navigation display for captain, another set for FO. In the middle, these two displays, we call it ECAM. So on Boeing, this is known as ICAS. So Airbus, we call it ECAM. The upper ECAM, we call it engine warning display, and the lower one, we call it system display. Then we have a glare shield. Glare shield is an extension coming out to reduce glaring to the main instrument. Okay, displays. But what is on the glare shield? We also have some panels up. So we have master warning and master caution lights kept on the FO side. We also have a flight control unit for short-term autopilot control, and also we have a EPIS control panel to control navigation display. So you can display different information on the captain and FO side. So on the center pedestal, what do we have? On the 330, you will find 1, 2, and 3 multi-purpose control and display unit. So there are a total of 3 MCDUs. And then you have a audio control panel and radio management panel for communication. One for the captain, one for the FO side. Then you have engine-related controls. We have a thrust lever, we have a master switch. But in this picture shown here, you've got 4 master switch and 4 thrust lever. Because shown here is a 340. So for 330, we only got 2 and 2. Okay, what else we have? A speed brake control handle, and also a flat lever, and also a parking brake. This one is the rudder trim panel, and this is the printer. Okay. Anything else? Landing gear control is here. We have the landing gear lever and also landing gear indications. Over here we have an integrated standby instrument system, which is a backup primary flight display for instrument flight. So on top we have an overhead panel for the control of most of the systems. So if you sit onto a captain and a FO seat, you can also control the rudder. So we have the rudder pedals. If you press up and down, they will control the brakes when the landing gear is on. So any questions over here? Good, huh? Okay. So let's start with the overhead panel. Okay, on the overhead panel, the systems is arranged in a logical manner. So those engine-related systems are like engine fire, hydraulic fuel, electrical, and air system. It's in the middle. On the left, we have a air data inertial reference system. We have a RU panel, a fire, flight control, okay, emergencies panels, GPWS. We have a wiper control and pulse panel. On the right-hand side, we have audio control panel RMP number 3 for backup communication. And we still have a few more flight control switches, cargo aircon panel, ventilation panel, engine manual panel, and then a wiper for the FO side. Okay. On top, we have a maintenance panel. This one is more for maintenance on the ground. There are some selections that you can do. And one of the special features of the 330 is that there's no physical circuit breaker in the cockpit. Okay, what we have is a computer reset panels. So we have one on the left and one on the right hand side. It looks and feels exactly like a circuit breaker, but what it does, it just soft reset the software part of a computer, so it doesn't cut off electrical power. Okay, so it serves a different function. So we call it computer reset switches or reset panels. So on a 330, there's no physical circuit breaker inside the cockpit, because from the cockpit you can open the door and get down to the avionics compartment. So the physical circuit breakers are all that they are located inside the avionics compartment. Okay. Okay, on the glare shield, this is typical to any aircraft. So in the middle, we have a flight control unit, EP's control panel, left and right, okay, then master warning and master caution. So this portion, we also call it attention getters, because in case you have a warning or caution, the light will come on, you also get an audio warning, so that pilot will be aware on the urgency of the defect. If it's a warning, it will require immediate action. If it's a caution, you need awareness that certain system has failed, but no immediate action is required. Okay, main instrument panels, we have total of 6 display units, which are interchangeable. Okay, but depending on where you install it, it will serve a different function. Okay, so first thing, we have an electronic flight instrument system, which includes of primary flight display and navigation display of the captain, another 2 for FO. In the middle, we have engine warning, engine centralized ECAM. Okay, you have an ECAM panel in the middle, so the top one is EWD and the lower one is system display. Okay. So for Airbus, we also have a very nice sliding table where you can take it out, where you can put your manuals and read on top. You can also enjoy it in flight wheels. If it's stowed, you can fold your legs, so it's really spacious on Airbus. Since the size they get at the side. Right. So on the right hand side of the ECAM, we have a landing gear related controls. We have a landing gear lever. There's one special function here. We call it landing gear emergency panel. So this landing gear emergency panel, if you select the landing gear down, it will deploy the landing gear under gravity extension. But it's using electrical motor to deploy it. Okay, for deployment. Right. Okay. So I think that's it. We have a physical clock here, which is running on top battery bus. Okay, so the last topic for today will be the center pedestal. Okay, so the center pedestal, what do we have? Okay, so firstly we have a 3 MCDU. So because the wide body aircraft, you got 3 MCDU. And the third MCDU is very convenient for maintenance personnel because the third occupant seat is immediately behind the center pedestal. Okay, so you can actually sit here. For maintenance, you can use MCDU number 3, where the captain and FO is using 1 and 2. Okay, so this can minimize interference during aircraft operation. You can do your tests and get all the fault code, okay, for troubleshooting as well. Okay, just a recap what we have here. We have for communication, radio communication, we have RMP and also ACP, radio management panel to control and select frequency, and audio control panel for transmission and reception. Okay, so for engine related systems, we have here master switches, thrust lever, we have a manual trim wheel for the THS control. You can change the display of the lower SD by using ECAM control panel. Okay, so this one over here is the weather radar control. This one is the ATC control panel, where you can put in the spark codes. And then we have a spoiler lever, flap lever, engine mode selector. If you want to select engine starting or engine crank, you can do it from here. Okay. Cockpit door locking system. If you want to allow or deny entry from someone at the cabin side to enter the cockpit, you can make a selection here. Park brake lever. We have an electronic parking brake system. You can select it off and on. And then we have a rudder trim panel where you can trim the rudder to maintain a straight and level flight. And lastly, we have a printer. Okay. So if you want to print out any maintenance issues or any post-flight report after each flight, you can actually do it from here. Okay. And that's all for module 3. Any questions? All good, huh? Okay, then we'll take a 5 minutes break and then we will proceed with the last module, which is module 4. Okay, welcome back everyone. So we will continue with the last module. So last module, I will do a quick recap of all the systems. And then as we go on each page, there will be a Q&A session. So I might ask you some question, or if you have any question, you can ask me. Okay. So yeah, okay. Airbus is produced by the joint effort of different countries. So what are the countries involved normally? Which is part of YASA? Europe. In Europe, yeah. What are the countries involved? German, France, UK, and Spain. Okay. So these are the 4 main players. But there are also certain smaller components which are manufactured, something like a Belarus. But nowadays, the production, just for information, is not only focused on in Europe. In North America, we do have a final assembly line. In China, also we have Airbus manufacturing. Okay, that's good. Okay, so this picture shows you different areas which are manufactured by different countries. Okay, so for 330, what are the engine options? We got 3 engine options, right? 330. Yeah. Okay, remember over here? So these are the 3 engine options: Rolls-Royce Trent 700, PW 4000, and GE CF6. Which engine is the heaviest? The largest and the heaviest engine out of these 3. Trent 700 is the largest one. Okay. One of the things about why is it largest? Because one of the reasons is that it's a 3-spool engine. Okay, the rest is just 2 spool. We have N1 and N2. So for Rolls-Royce, I think it's their trademark thing. They have N1, N2, and N3. More components, and the engine itself is heavier and also larger. What are the engines used on the 340? Any idea? 340 only? CF6, CFM56 actually, which is used on the 320. But I think the thrust rating is higher compared to a 320. So we use 4 smaller engines so that it can fly a longer range. Okay, then we have aircraft zones and stations. You can find all under 1806. What are the reference axes? Dimension, section, and station numbers. Access panels. If you want to locate access panel, you can refer to 1806 and also zone presentation. Okay, what are the 3 axes on the aircraft? XYZ. XYZ, correct. The XYZ. So just like any other aircraft, X is a longitudinal, lateral, and Z is the vertical axis. Where is the datum line under x-axis? Where is the datum line for the longitudinal plane? Is it at the tip of the rudder, or is it forward of the rudder? Forward is an imaginary line. You need to measure 251.2 inches in front. That is datum line 0. Okay. Very good. Okay, aircraft dimensions. Okay. The wingspan of both Dash 2 and Dash 300 is the same. But what about the fuselage length? Which one is longer? Which one is shorter? Which one is longer than the fuselage? Dash 2 or Dash 300?
Dash 3.
Dash 300. Okay, so the shorter variant is a Dash 200. What about the vertical fin? Which one has a taller vertical fin? Dash 2 or Dash 300?
Dash 2.
Dash 2, the shorter fuselage will require a taller tail fin. Okay, so Dash 2 has a taller tail fin. Okay, so next, we can also find station numbers under AFM chapter 6. So station 1 is the forward pressure bulkhead. The rear pressure bulkhead is a frame ATD. Okay, but the station number might change depending whether it's a Dash 200 or Dash 300 because you count from the datum line. Okay, so yeah, this part I forgot to mention. Actually, on a 330, there's no overwing doors. What you have is 8 full-size doors. So we just name it door number 1, number 2, number 3, and number 4. So number 1, 2, and 4 has the same size. You have a dual lane escape slide or slide raft depending on the EDTO configuration. So meaning 2 passengers can exit at the same time. But door number 3, standard one is a bit smaller. So only 1 passenger can evacuate at one time. But you can also do a modification to change it into a larger door. So depending on the configuration of door number 3, it can be a smaller door or a larger door. Okay, but anyway, those are just full-size doors. Okay, so over here, just now we have covered the largest engine and the longest one. Okay, from external one, it looks like that one is a Rolls Trans 700. Then we have BMW and G. Now, zone numbers. So we just want to test out. Where is zone 100? Zone 100 is the lower fuselage. Where is zone 200? Upper half of fuselage. Zone 300 is on the empennage. 400 is the nacelle pylon. 500 is the left-hand wing. Right-hand wing is 600. What about zone 700? Landing gear. And lastly, zone 800. Those are doors. Okay. Now, talking about the doors, avionics door is also part of the zone 800. But for 330, there's only one external avionics door because once you go inside, you can actually walk freely inside the avionics compartment. Okay, it's a wide-body aircraft. Okay, 2 variants are Dash 2 and Dash 3. So servicing locations, this one is just nice to know. This one we have recap. But just a reminder, external power supply and then aircon supply and the HP supply, all of them we have 2 connections compared to a narrow body. Narrow body only have 1 connection each. Okay, so the servicing equipment is parked near the servicing panels as usual. So for passenger boarding, normally we use the left-hand side or right-hand side. Left-hand side. So cargo, we use the right-hand side, and catering, we use the right-hand side. That is one of the reasons why the cargo nose is on the right-hand side, because most of the airport operation is like that. So where are the main jacking points of the aircraft? Main jack points. Nose. We have nose and the wing up. Okay? The tail one, we just call it the safety point. This one is more like the safety state. Once you have jack up fully, that one is more for extra support. Okay. What are the methods to check leveling on Airbus? The easiest method, if you have electrical power, we go to MCDU, AMS, Alpha Collar. You can do it using electrical power. You can read digitally. Okay. If you don't have electrical power, then we use a spirit level. Or if you have altitude monitor, you can also use this for quick leveling check. Okay, aircraft weighing, normally we just use a weighing scale, right? So we just throw the aircraft on top of the weighing scale, and then you just read what is the reading. Aircraft towing operations, we can find in AMM 09. So do observe the precautions. Make sure we use a proper tow bar, and then the servicing dimension, the servicing band is correct, dimension H, not under service, not over service. And observe the maximum towing angle, and also fasten the seatbelt. Okay, if you are sitting inside. Okay, turning radius compared to between dash 2 and dash 300. Dash 300, since the fuselage is larger, you will need a slightly larger turning radius. Okay, out of this 3 engine variant, which engine exhaust thrust will travel the furthest? Trans 700, so compared to the rest, it's 640 meters, compared to 200 plus, so almost 2 to 3 times. So be very careful. Okay? Trans 700 thrust is actually, the exhaust is actually more dangerous compared to the rest. So for safety, this entry corridor only up to minimum height. Okay, but I will not suggest to go near to the engine even at the minimum idle. Before minimum idle, we should run away. Okay, parking procedures. Right, parking procedures. We need to install the ground safety devices okay, to make sure the landing gear doesn't collapse and make sure we choke the aircraft. Okay. So anything we need to do on the fuel tank during parking? On the fuel tank, do we need to do anything? Water drain. We need to do water drain. Okay. And don't forget the trim tank. So trim tank, you need to use a highly filtered water also. Okay. Even though the trim tank itself is a carbon fiber structure, we still need to drain water because you still can get microbiological growth. Mooring. Okay. When do we have to use mooring? High wind conditions, prevent the aircraft from hopping and jump show. Can refer to 8810. Can only use registered toolings because unregistered toolings can be left accidentally on the aircraft. Okay, so for tooling, for special tools, we can refer to ITAC, illustrated tools and equipment manual. Ground support equipment and tooling, make sure we use the proper one, which is compatible to 330. Right, we have 3 types of decals available. So again, just a recap. One decal will tell you component location, one is for access, and another one is for maintenance procedures. Okay. Which ATA chapter for decal? ATA 11. That's good. Right. So we go into the cockpit. Do we have any control column or control wheel on Airbus, on the modern Airbus?
No.
No, if you work on the Airbus A300, A310, you will find it. But for 320, 330 onwards, they have changed to fly-by-wire system. So what you will find is just a side stick. Okay. So how many display unit? 6 display unit. How many EPs display? 1, 2, 3, 4. How many ECAN display? 2. So where are the system switches located? The system, push buttons to control various aircraft systems. Overhead. Yeah, you might find on the center pedestal and also on the overhead panel if you want to control aircraft systems. Okay. Do we have any circuit breakers on the overhead panel? Are there any circuit breakers?
Yeah.
Okay, this one green color one, but we call it the reset switches because it serves a different function. You don't interrupt electrical power. Instead, when you pull this circuit breaker look alike, this reset switch, it just reset the software part. Okay, so we call it the soft reset on the Airbus. Okay. So there's no physical circuit breakers like breaker. Okay. On the glass shield, we have master warning and master caution light. What is in the middle? FCU. Okay, we have a flight control unit for short-term autopilot. Again, main instrument panel. Okay. How can we bring down a landing gear under emergency configuration or for gravity extension? We use this one, okay? It's an electrical switch. So we use landing gear emergency panel to do that job. So it's an electromechanical system. Okay, so we have 6 display unit, 1, 2, 3, 4 EVs, 2 ECAM. We have a physical clock as well. Okay, lastly on the center pedestal, how many MCBUs? 3, yeah. Okay, because the white body, we have a serial number 3 as well. Okay. Then we have a printer. The rest is very similar to 320. 320 and 330 actually, if you know where is the component location of each one of them, you will not get lost on Airbus. The layout is very, very similar. Okay. Okay, and that's all for our Module 4 and a Q&A session. Do you have any further questions? Good? Yeah.
For the maintenance personnel possible to get the aircraft to deactivate the flight mode.
To deactivate the flight mode, you need to pull the proper circuit breakers. So normally we pull circuit breakers in such a particular sequence. We have to kill off the prop electrical heating first, and also the window heating control circuit breakers, and then we will have to pull some other circuit breakers like PHC and also this WHC, followed by LGCIU and EIVMU, okay, on the 330, and only you check out the aircraft. So you need to locate for a procedure, we call it preparation for flight mode, then you just follow step by step to prevent any accidental flight mode activation. Then only we check out the aircraft. Okay, any other questions? Good?
Yeah,
So,
good.
no question, okay, thank you very much. So
Thank
we have
you.
completed our training.